Welcome, everyone. Thanks so much for joining this month's Tech Talk series. Today, we'll be deep diving into a critical and important topic, migrating C++ applications to Java. I am Joe Raffanelli. I'm a director here, technical solutions at Microsoft. For those of you who are new to the series, right? So Microsoft is a leading custom software development company. We specialize in transitioning legacy systems to modern platforms. I am super thrilled today to talk to my colleague, Bassir Kwari. He's a senior consultant at Microsoft. He's an architect here at Microsoft, I should say. Together, we'll discuss the important subject that enables IT leaders to make strategic decisions as they navigate modern efforts. So here's how it's going to work. As most sessions that we do this, will flow this way. I'll kick things off with a few questions, get things warmed up, and then we'll do the wrap up and ask folks to give chat questions. We do that. We're doing that for a while, and that works out pretty well. Bassett, I want to give you a second to introduce yourself, and then I'll get right into it.
Sure. Hi, everyone. Good morning, Joe. My name is Basit Kari, and I have about 20 plus years experience leading application development in general, both building things from scratch as well as, migrating legacy code to modern platforms. Most recently, I'm leading an effort to convert a very large C++ application to Java platform for a global data provider who specializes in intellectual property data with rather complex and unstructured data and workflows. So that's my intro.
Absolutely. So you're definitely the SME on this, subject matter expert. So let's kick it off here. So C++ was very popular, is very popular, and is a solid language today, right? So please give the audience a brief on C++ language and why to migrate the application.
Sure. C++ is a powerful, language with high performance programming capabilities, as well as it's widely used for systems development, software development, game development, and real-time systems, and many more. Actually, it's not just limited to those areas. But over time, many C++ applications become complex and challenging to maintain due to manual memory management, and also due to evolving business needs, and it may not provide as good a enterprise support as some of the other platforms do. So migrating to modern languages like Java offers advantages such as easier memory management, scalability, cross-platform support, which is something a lot of companies want to do these days because they don't want to be bound to one platform, as well as easier memory management, overall scalability, and access to modern development tools, which can significantly reduce maintenance costs and improve productivity. The C++ has been around since 1985, so it's been there for a while, and in many environments, it's considered legacy by companies because of diminishing talent pool as well as availability of a lot of new modern tools and languages. So hence the need for migration.
Yeah, definitely makes sense. We get a lot of calls about the diminishing pool of folks being able to, code a particular language, and also the maintenance costs. That's a reduction. I'm sure that resonates, with our viewers.
Mhm.
So, my next question: what kind of programs were typically written in C++?
So C++ has been the go-to language for performance critical applications. So that's because it works as close to hardware as some of the assembly languages of the past. So it's super high performance in that sense. So it's perfect for building operating systems, game engines, very high performing financial trading systems. A lot of Wall Street type applications you'll find still exist in the C++ environment. Embedded systems, again, this is code that that works very close to hardware, and a lot of legacy enterprise applications as well. So the speed and efficiency make it ideal for applications where performance was non-negotiable. That covers most of the areas where the language is used, but I'm sure that it's its appeal is broader than that as well.
Makes sense. Thank you for that. So besides Java, what other options are available for C++ applications?
To migrate, yeah. So that's a good question. So apart from Java, organizations often consider languages like C#, Python, or even Go, like Golang, which is quite popular these days for its cloud support. C# because it's popular in Windows-based environments and the entire sort of Microsoft ecosystem that surrounds it. Python is really a very versatile language. It's probably the most versatile these days for a variety of reasons, especially for its data engineering support, data science support. It's the language which practically can integrate into any system these days. And like I said, go for its performance and in cloud native environment. However, having said that, Java stands out for its platform independence because you're not writing code that is specifically to run on a Unix platform or a Windows platform or anything like that. It's running in non-Java virtual machine, which makes it easier to support cross-platform environments. And its extensive ecosystem and a whole bunch of third-party libraries that are available because the language has been around for some time also. So it makes it a solid choice for many enterprise migrations for that reason.
Yeah, that makes a lot of sense. It's nice that it has a couple different options, but Java definitely, as you explained, it definitely stands out. So whenever we're doing migrations, folks always ask us about tools. So I want to ask you the same. Are there any tools that can help migrate C++ code to Java or other languages?
Yes, indeed. There are several tools that can help in that regard. Specifically, there are tools like Tangible Software has a code converter between C++ and Java. Gradle JCPP also can help wrap C++ code into Java integration. Lately, though, with the advent of AI and LLM, there's been a number of tools that have been wrapping up the LLM's code conversion capability. That'll take you from one language to another, and C++ and Java are no exception to that. So that allows you to do a first shot, code conversion. We have at Microsoft, we have a tool called Code Auto, which has been used in that regard in the project that I referred to that I'm working on right now. The idea is that you convert individual source codes, components or programs, and then you try to put that into a unified architecture. But it does it takes care of the first 20 to 30% of the work very nicely, and that's what that's the approach that we're proposing these days for a lot of customers.
No, well said. I know you mentioned Code Auto, one of our tools. We can share the link with folks, and if folks can actually play around with it. But we use it all the time, like Bassett had just said. So it actually does simplify things and makes things a little bit easier. There are no easy buttons, folks, by the way, but it definitely makes things more manageable. Okay, so there's always issues, right? There's no easy button when you're moving over to a different language or different framework. So maybe you can just let folks know what do you foresee? It's like, what challenges do you foresee in migrating C++ applications to Java?
Yeah, that's a great question, and that's what brings the topic to real life in a sense, because a lot of times organizations going through these projects, this is a fundamental question. What are the risks involved? Where we may need additional help. So some of these challenges include memory management differences, because C++ uses manual memory management, which is great for efficiency when you're working at a fairly close to hardware level type of work, but it becomes a management issue, code management issue very quickly. And Java relies instead on garbage collection, which means it manages the memory automatically. And in order to make sure that switching from one, platform to the other, you don't have a big impact on performance. You need to optimize that code. So that's one. Then obviously the other issue, which is related but different, is pointer and reference handling. C++ is big on pointer references to specific memory locations, again, which makes it very efficient. But again, it also makes it difficult to manage that code. So Java would require some sort of refactoring of that code into into an environment that doesn't support pointers. And that could be quite complex, because this is where you're tweaking the code actually, rather than just blindly converting from one language to the other. Real-time performance is an issue, obviously, because C++, as we said, is well known for its high performance and efficiency, and to be able to replicate that in Java could become an issue in some applications, although a lot of the enterprise applications should do just fine in either environment, because they're not expecting sub-second response time or transaction times and so on. So but if it is a performance sensitive environment, I mean that additional tuning would be necessary, and that could pose some challenges. Another area is dependency management, where basically your code is making calls to outside software components, and the challenge there is whether that code is going to integrate with the destination language, in this case Java, as well as it does with the source language, which in our case is C++. So there's got to be some homework that is necessary to be completed in that regard. And then mostly, since C++ is fairly low-level language, even though it's a high-level language, but you can do a lot of code, close to hardware level type of work. Sometimes you can have a situation where the application is like an embedded system, for example, where the code is very closely tied to the platform itself. And that doesn't translate too well in Java environment, because Java is not tied to a particular platform. It needs to be able to generate something that runs as bytecode on its virtual machine. So they could be. So I guess special attention has to be paid in such scenarios. So, however, with proper planning, risk assessment, and phase migration, you can help mitigate some of these challenges.
Very well said, and I think the audience likes to hear it and actually see the slide there, so that really resonated. It's something where it actually makes a case where it makes sense to have a third party actually helping, like a migration service company, actually do this kind of migration, because it's certainly there are certainly some hills to climb there. So I'm glad you pointed that out for folks.
Mm-hmm.
The other thing I want to talk about next is, what are the best practices for successful migration of C++ applications to Java? So just looking for, what best can be done.
Yeah, I think each migration is unique in some sense, because each application is unique. However, there are some, overarching considerations that you should have in terms of what are the best practices. One is to be able to assess the work at hand and plan accordingly. So really have a good understanding of the code, and identify complexity, scope, dependencies, potential risks, and so on, so that we're entering the work with a solid understanding. The other thing is to approach it in an incremental manner, meaning identify areas which are most amenable for initial conversion, and that can be tested and validated before you commit to the entire project. So and it will also allow for continuous validation as you proceed. The other things are related to testing. These days, I mean, test-driven development is quite popular, and it requires you to have developers do some initial unit testing before they even commit their code to the repositories. So we strongly believe that's a great practice to have. On top of that, the actual QA, a lot of the tools available today are automated that make it easier for doing regression testing and validating what's been delivered. And so that's another great best practice to have. And again, like I said earlier, you can probably use an LLM based approach to get to maybe 35% of the migration, but then you have to really dig deeper into the code and do the rest of the migration by making adjustments to compensate for the differences in languages, like we talked about, like pointers and memory and so on. And that phase requires a lot of refactoring, rethinking. Sometimes the organization may require that a big backlog that has been waiting, that couldn't be implemented on the old platform, now needs to be brought back into the picture. So that makes it more of a mix of a migration as well as sort of re-engineering project. Again, it varies, from company to company and project to project, but that could be a way to handle it. And obviously, the other thing is that since C++ is very performance-oriented environment, you need to be able to do benchmarking and performance as you proceed. So there's got to be some, upfront thinking and investment in that area.
It's a very comprehensive list. Thank you for putting that together. What resonates with me is a lot of testing, right? Unit tests and automation testing. I know we want to make sure the application works very, very well. And if folks do it on their own, they would have to do the same. It's very important. And then performance benchmarking, that always comes up, with our clients. So we make sure that performance is where you expect it to be. Otherwise, we got to do a deep dive. So those are some really good points you made. Okay, so now we have the best practices we talked about. So how are we measuring success once you migrate it? How are we measuring it?
Yeah, I think like any other project, this should be front and center. I mean, you have to have a clear understanding of how you're going to judge the success of the migration or the conversion project. Number one, there is to make sure that the new platform delivers the same capability or more that the existing platform does. And this is easier said than done. And this is where a lot of the testing effort that we talked about, comes into play, specifically the automated testing and the need to have really, really solid user acceptance testing that covers the entire scope of the application and the use and the test cases that are designed with that in mind. So functionally, the application has to meet the requirements. Otherwise, it's not a success at all. So this is really essential. Then the performance metrics, we keep coming back to that because the context we're talking about is C++ to Java, and C++ is claim to fame is performance. So you got to have those metrics. They could be transactional performance metrics. They could be response time from a user experience perspective, or any other aspect of performance that has to be guaranteed. So those have to be very well defined. And a lot of time, and the next one is maintainability, which is obvious because a lot of times the organizations are feeling the pressure to move from one platform to the other because their existing code base is not very maintainable, because it has collected a lot of tech debt over time, and it just becomes very difficult to handle. It doesn't remain very modern as it did maybe 15 years ago. So with that, the new code base has to be much more maintainable. Otherwise, really, we haven't achieved much at all. So another critical consideration. Similarly, scalability, which could be, you could view that in two ways. One is scalability from a technical perspective, that if your transaction volume grow 10 times, how are you going to scale it? So it should be scalable in a typical cloud environment, but also scalable from a functional level, meaning that whatever capabilities that you have put in have been thought of in a manner which is extensible and you can build new things on top of that, so that a new business requirement that comes in doesn't necessarily send you on a path to building something from scratch. So both aspects of scalability are important. And last but not the least is user satisfaction, which simply means that we have to keep in mind everything that we're doing is to help the users who are going to be using the applications every day of the week, and to make sure that their experience is better, or at least the same. And I think what makes it easy to achieve that goal is to engage those users earlier in the process, and get frequent feedback from them.
Absolutely. I'm looking at the list, and user satisfaction, I totally agree. It's got to be, it's very high up in the list, making sure those users have a good experience with it, making sure they're going to continue using it, making sure that performance is there. So,
one of the biggest challenges, Joe, that a lot of software projects have is adoption. Meaning you can build something which is great and very shiny and everything, but users don't use it. They continue to use the other
exactly.
old applications, and this is where it really makes it relevant.
Absolutely. Totally agree. Okay. Those were my initial questions. I'm going to see if there's questions for the audience. I think we have them already here. Okay. So how do you handle performance critical modules when migrating from C++ to Java?
Okay, so for performance critical modules, it's often best to profile the application to identify bottlenecks. These modules can be optimized using Java's concurrency features, or even rewritten in native code and interface using JNI if necessary. So the idea is that if you're not able to find a comparable solution in Java, at a minimum, what you could do is you could leave that particular component in the existing language and just interface to it.
Okay. Thank you. Question 2. What strategies can be used to migrate C++ code that heavily relies on pointers?
That is a great question, because Java doesn't support pointers. So such code has to be carefully refactored using objects in Java, such as arrays or collections or object references. Smart pointers in C++ can often be mapped to Java objects with garbage collection. So again, like I said, part of the migration project will be on autopilot, and you get to that, and then you have to have real developers dig in and tweak the code to achieve what you're trying to achieve.
The expertise is definitely needed there. I totally get it.
It's a combination of automation and expertise.
Yeah. Okay. We got another question here. Okay. So how do you manage third-party library dependencies during migration?
That's something you need to evaluate, and find Java equivalents for custom solution. Java has a vast, amount of libraries, third-party components that are available. If one is available, you can switch to that. If it's not available, you can, again, like we said earlier, you can wrap the existing original library as a service and continue to use it from within Java environment. So there are, but there's a good chance whatever that it is that you're doing, unless it's very narrowly focused, highly specialized area, you should be able to find something equivalent in Java.
Okay. Good enough. Anything else? Okay. What's the typical time frame for a C++ to Java migration project? I'll take that one. So the easy answer is it depends, right? It depends on the complexities of the application, the way the application is written. But to be a little bit more specific, if there's, let's just say 100,000 lines of code, we would typically take between 6 to 9 months to get it migrated. But again, I'll use the word depends again, right? It really depends on how that darn thing is written and the complexities. Okay. Any other questions here? All right, so we're going to close the session. So I have a closing statement here. So I want to thank everybody for engaging in this important discussion concerning C++ and the migration challenges and opportunities, right? We had a lot of great questions out there. We've explored the strengths of C++ and its legacy performance critical applications and the compelling reasons to consider migrating to a modern language, like a Java. So we also touched on complexities, tools, strategies, and best practices that can guide a successful migration project. So while every migration is unique, like we mentioned, the key takeaway is careful planning is one, incremental execution, right? Two, leveraging modern tools. Three, then best practices can be transformed, a legacy system into a future-ready solution. So whether it's either scalability or maintainability or improved performance, the payoff from such a migration can be significant from a business striving to stay ahead in today's competitive landscape. So thank you all for your attention. Special thank you to Bassett. He was a great SME for us, subject matter expert. If anyone has any other questions or comments, please let us know. You'll see my contact information there. For now, I'm going to close out the session. And until next time, thanks everybody for your time. Take care now.
Thank you.
All right. Bye.